My name is Mona Arsene. I work in product management, and I'm really happy to be here today. And actually, I had to change the slide deck that was initially planned for the session in order to present you the new idea that we have in the area of just enough operating system to kick off creativity. I think that the microphone works, right? And you can all hear me perfectly. Yeah, like this? Okay. Good. So it was last year at SUSECON when we announced the availability of JeOS, as we call it, or just enough operating system. And back then we said that what is important for us is to make sure that whatever we ship as minimal operating system, it inherits all the benefits of SLES. So that means customers don't need to recertify. That means that all the extensions and modules are available for this new version of SLES. And on top of this, we really wanted to go on the journey of making everything as small as possible. And this has triggered a lot of challenges for the engineering team in order to make sure that they put on JeOS what is really relevant and essential for the operating system and nothing more. And I think that we made a nice journey, and we managed to accomplish that. The current JeOS that was released in November and then has seen refreshes in April and during the summer, so in July. And very soon we'll see another refresh for SP2, inherits all the benefits of SLES. So there is no need to recertify SLES. There is no need. You have all the extensions and modules. You really have a minimal virtual images that is ready for you to use it. It's easy to download it and just get started as soon as possible. The other part that we managed to deliver is the template. So you are able to rebuild JeOS on your own, as well as you are able to add additional packages on JeOS as you need it. So JeOS sounds cool, right? Sounds everything that you ever needed, everything that was there for many, many years. So why are we having a talk here? Why don't we just go download the image and just go ahead and see what's in there? I'm going to explain that in a second. But before we go further, there is another concept that is important in the area of the minimal operating system, and that was introduced in SLE 12, and it continued to work on this concept. But that's the idea of modules. So what we have done over the last couple of years is we try to mix together the requirement that we have from one set of customers, which was to always maintain something for a long period of time, sometimes even 5 years, 7 years, 10 years, and so on, with the requirement of other customers that are going into the direction of, I want to get the latest and greatest, otherwise SLE is not relevant for my infrastructure. And we always try to balance that. And we came in front of you many times telling you, no, we decided for this version of PHP, we decided for this other version here and there, because we think that this is the version that is going to be long-term supported, and that's the version that your operation and development team should consider using. With SLE 12, we tried to do a different, we tried a different solution that it's actually working very nicely at the moment. And that is the concept of modules. So what we did is we isolated the part of the operating system that we call base operating system. And that is sometimes, that's not necessarily JeOS, that can be larger, that can be bigger than JeOS. But the bottom line is this is the part of SLES that we currently ship as SLES. And then everything else that had a different life cycle or a specific use case, or any subset of packages that could have been encapsulated and shipped as a separate repository was encapsulated into a module. At the moment, we have a set of modules that address different needs, like web and scripting, that are going after developers, definitely shipping there all the latest technologies. We have modules in the area of public cloud, as well as modules like legacy, where we have the packages that we plan to drop, but they are still going to be there until we see that there is no need for those packages. And of course, we have new modules like containers or certifications that are helping us manage the innovation in this area. So back a little bit to JeOS. When we talked about JeOS, you said that it inherits everything JeOS inherits all those modules. So if you want to start something today, you can actually give it a try to JeOS as a minimal image, then add the modules that you need on top of that, and you can have a very functional operating system that is ready for you to use and deploy everything. Now, when we talk about who is going to use this, we usually end up in these scenarios like DevOps. And when we look at the reality check for DevOps, we see this, and I found this very nice picture that really helps me articulate my idea. So when developers talk about DevOps, they mainly talk about Docker, right? So they talk about containers, their technologies. You learn Docker, you actually now do DevOps. It's easy, it's there, it's simple. So the learning curve for this, it's really, it's something that is manageable for most of the organization. When DevOps looks into operation, there are actually multiple layers on top of Docker. So of course the operational team needs to learn about Docker, that's going without saying. But then they need to learn about Kubernetes and how to handle the network and how to do the rolling deployments and the monitoring and the logs, the system logging and everything else. And that becomes a problem because you can see the adoption of DevOps, it's going to be easier in the development part, on the development part of the slide, and much more challenging on the operational side of this slide. And this is where at least the goal of this session has slightly changed. And as we want now to introduce a new platform that will actually help the operation teams deliver the solution and have this available for their internal customers. And we currently call this SUSE Containerized Service Platform. And this has the following priorities or use cases. So we are going to look at develop as providing something that where customers can manage their workloads across environment. So it doesn't matter if you are running your application in your data center, or if you're running your application in your data center in the cloud, or you need to do a mixed environment, this solution is going to help you scale out your application. And we are going to make sure that we move from the idea of things have to run on one machine, even if my laptop or my server or so on, to the idea that things have to run in a cluster, where the whole situation becomes much more complex because you no longer know exactly where your application is running and what is happening in that situation in that cluster. So the core concept of this is that we are going to glue together or put together three main components. The first one is the SLE microOS. The second one is Kubernetes, and the third one is Docker. Now let's look a little bit what this really means. So the SLE microOS, this is a new type of operating system that we are going to build and ship, and we are going to talk about the time frame in a second. And this is really targeted for cluster deployments in a world or in an environment where everything is container. So when you think about microOS, you have to think in a data center where containers are already there, where the mindset of developers are all around Docker and how cool Docker is and how cool containers are. And in that environment, we need to look at a different type of operating system that is going to fulfill and facilitate this deployment and solution. The second part is Kubernetes, and this is a well-known open source orchestration solution, and we are going to work upstream on the Kubernetes. We are going to always go with the latest version of Kubernetes. This will help us manage the different use cases in the area of orchestration. So how do you manage multiple containers? How do you handle the workloads between different containers? And of course, when we talk about containers, we need to talk about Docker. So in the area of what is microOS? So we want to build a modern operating system that is really designed for containers and have in mind the idea of large deployments and large clusters. And microOS will definitely inherit all the knowledge from SLES as well as all the benefits that SLES brings while redefining the operating system. Why should we look at this? I already mentioned DevOps. That's one of the important use cases. Most of you are already facing the situation where in many accounts or in many discussions, you know that DevOps sounds very good for developers, but it's really challenging for operation. And with this product, we really want to go and help the operational teams embrace the DevOps and have a solution that really fulfills their scenario. The second part is this will definitely accelerate the business innovation. So now, finally, customers will be able to easily deploy their application, to easily change setups, and as well as manage the scalability of applications when needed. We bring on top of this the enterprise flag. So we are not going to just do things in a startup way. We do it and then it crashes and then you have a critical situation. We are going to make sure that everything is ready, it's stable, it comes with an enterprise support solution. And this will allow you to run your applications anywhere you are and scale out as much as you can. So what problems are we trying to solve? Today, there are many customers that are, so when you look at the operating system, when you look at SLES today, this is a monolithic operating system that has multiple use cases, that fulfills the need of in multiple scenarios, and it's seen as a stable enterprise-ready solution that enables you to run your applications and enabled you to run your application across multiple life cycles and so on. However, when containers came in, we realized that SLES has become too big for a container. This multiple purpose operating system, which has been and continues to be one of the key benefits of SLES, has now become one of the impediments when you look at containers. And this is a situation that it's identified by SUSE as well as other vendors when you look at how containers are going forward. So in this context, we really want to make sure that we have a small, ready-to-use operating system that is targeted for containers and is focused on this type of deployment. And if we go a little bit deeper into what exactly will MicroOS include, our plans are to really look at the installation and make sure that we have a small and ready-to-use image that is going to be deployed on bare metal. So that means you can have this solution available on physical hardware, and you can start with that when you look at your deployment. The second is we are going to deliver virtual images for MicroOS as we do today for DUS. So you will be able to get virtual images or MicroOS if you are running this on top of virtual environment in a public cloud and so on. And the third is we'll make sure that the configuration it's made as easy as possible. So there are different solutions that we are evaluating at the moment. We are definitely going to take advantage of the SALT stack that will help us to manage the configurations and get everything aligned, as well as have a smooth integration with SUSE Manager. In terms of scalability, we really assume that you are going to use this scenario for more than 25 nodes. Of course, you want to give it a try on a machine or on a development setup, but if this is interesting for you if you have more than 25 nodes. And if you have more than 200 nodes, that it becomes even more interesting. In terms of updates, we are introducing a couple of interesting and really cool concepts. So first of all, we are introducing the concept of a transactional update. That so far we have shipped our updates as RPM. So there are individual small updates and packages that we ship into our update repository. Now we are going to make sure that we collect all those updates into one update that is going to be applied as a transactional update to the system. So once the update is into the system, the update will automatically be applied to the system. If there are problems with this update, then the system will have the capability to roll back to a stable state. So with this, what we actually introduce is a self-updatable operating system that will not only have the functionality of always go to the latest version, but as well as if there are problems, go back to a stable version and do not affect my infrastructure. This functionality is going to be implemented using core functionalities of Btrfs. So we are going to look into the system rollback and snapshot that we have already introduced and advertised during the last couple of years with Btrfs. We know that not all of you are able to trust a self-updatable operating system. So some of you will say, that's way too much for me. I need something where I can still have the control. It's hard to just let it go. It's hard to let the gear go and say now everything is going to be self-updatable. So for that, we are going to introduce the concept of a maintenance window, the time frame where we can say during let's say midnight and 1 a.m. or something like this, do this update, and if it's out of this, then roll back to a stable version. Or if we cannot make it into that period, it's just do not make the update, because it's critical for my infrastructure that everything it's available for my applications. So are those ideas kind of clear? Do you have any questions so far? Yeah.
I'm just curious. So what you are planning to update, I don't know what you plan to update the template that creates the containers, or going to be update the containers?
So we are planning to update the operating system that on top of which the containers are running. So we will have a stack. We'll have the container host operating system, and this is going to go into the auto update cycle. Then we will have Kubernetes, where we have the plan to have rolling updates. That means once a new update of Kubernetes is going to come, you're just going to naturally go to the latest. And then containers are on top of this infrastructure. Yeah. Yes, please. And that's a natural question, right? So JeOS is a general purpose operating system. That means you can use JeOS in any environment. You can use it with containers, you can use it with virtual machines, and soon you're actually going to be able to use it on the installation as well. And JeOS comes with all those less benefits. You have all the extensions, all the modules, so you can put high availability on top of JeOS. You can put all the modules that I just talked about, like web and scripting, legacies, containers, and everything. It's available for you. It has this mindset that it's just a stripped down version of SLES, right? So it's just something that as small as, you give it a try, and then on top of this, you can just put additional packages as you want. So if you miss one of the packages from the JeOS distribution that we ship, you can easily build in, have it in, and then you get into that. As well as with JeOS, it's very easy to move directly to full SLES. So you can give it a try to JeOS saying, well, this is not really working for me, I want the full SLES. You can just very easy update from JeOS to a full SLES distribution. MicroOS is mainly container focused. So we really look at MicroOS as the container host operating system. If you are outside of the container world, MicroOS is not important for you, not even relevant at the moment. So if you are not interested in Kubernetes and running a container as a service platform, and this containers is not something that you are interested in, then MicroOS is not a solution for you. If you are interested, then you have to decide what is more relevant for you. So it might be that you just want to run static containers, right? So you just want to have a couple of containers that are running on top of a virtual machine and so on, and even their MicroOS might not be relevant for you. But if you want to go the full stack with containers, that means your entire application now runs only on containers. For that, you need a container orchestration, which most likely is going to be Kubernetes, and that needs to run on top of something, and that something is MicroOS. So that is the transition from a general purpose operating system that has a favor or that has an additional layer, which is like JeOS or something smaller that you can start, to a focused operating system that it's only designed for containers, large scalability, where we really think that manual intervention and so on is not something that you will ever want to do that area. It's a transition, so. Yeah. Do you want to take it, Thorsten? Yeah.
No, we don't plan it, but in the theory, it's possible that it will be done. So, what happens, for example, simply C, so you simply C, emulate estimates and send it to different customers, whatever. You could also use technology and uses whatever snapshots and emulate them. The technically it's possible, but currently we don't plan it. If there is customer demands, if there is development, maybe we change our minds, but currently we are doing bootstrapping it if there's something to start to discuss as customers, it's just a sort of market needs what they expect, or expect something better or if you want, I can insert you as you have some iOS instance coming.
Okay. So in terms of, and we already touched some of those points, in terms of what is different on this, so I think that we mentioned already, so Btrfs is going to be the default file system, and we are going to use core functionalities of Btrfs to make sure that we can handle the transactional updates. The second part is we are going to continue to use RPMs. There are vendors out there who decided to drop RPMs. This is not our decision, so we'll continue to use RPMs, and we need these solutions in order to make sure that the transactional updates are in good shape, they are signed, they are verified. We don't need to reinvent the wheel here. We are going to use our build infrastructure to make sure that this is properly built and you can all rely on that. And of course, the security certifications, we are going to ensure that they are kept and they are available for you on macOS. The other part, this is more important if you are already familiar with the other vendors that are out there. Very important for the macOS as one of the differentiator compared with other vendors is that we already have a partner ecosystem. We have ISV certifications that we plan to maintain, as well as we have a set of partners that are willing to work with us on making this available, things that you might miss on other distributions. In terms of the schedule, so we are now publicly talking about this. We encourage you to visit the kiosk as well as just grab us and talk about this if you are interested more in the solution. We will have in March an early access program or a public beta where you can just join the program to have access to the software, test it, and see how it works for you. And we plan to have a first customer shipment of this new platform somewhere in July 2017. So the bottom line is, this is really coming, and we are quite excited about having a platform as a service solution available to give it actually to you, to give it a try, to see if it makes sense for you, to see how it works, to see how you can make actually the transition from the classical data center into a containerized data center where containers are actually running everywhere. And hopefully that will help you even with the multiple vendors where you have solutions in-house as well as public, or you are using public cloud and other solutions. Those are all my slides. I'm just curious if there are questions, or which are your thoughts? What do you think about this? If this is relevant in any way. You need the solution, yeah. Sorry. So Torsten, he's the architect for macOS, and he has already, as he mentioned, he can show you macOS at the booth, as well as we'd like to keep in touch if you are interested. So we have now a public mailing list you can subscribe, and we are going to inform you about what's happening and what's coming up next.
We are also shipping Kubernetes which will be used for this,
Yeah, so we see more this as a platform that is going to be used either by customers that are just trying out DevOps or are just trying to figure out how things should work in their data center, as well as small installations or medium to not necessarily small instances of containers, so medium-sized installations. When you talk about OpenStack, it's a project that requires a large deployment as well as training and learning for that. So that is an investment from the organization. And the way we see is that this can be a first step, and then you can actually upgrade to the full OpenStack that brings much more benefits than this stripped-down platform. Let me just go back. stops here, sorry. So the idea of that graphic is that a micro OS plus Kubernetes is going to help you manage everything that was on top of Docker, from the networking to the security to the log management, monitoring, and so on. There's going to be either Kubernetes alone or additional modules that are coming on top of Kubernetes, like additional add-ons, as Kubernetes calls them. Yeah, Kubernetes comes with additional add-ons. As far as I know, for example, the monitoring, it's an add-on on top of Kubernetes. And we have the plans to ship all those add-ons available for you. It's just that from a migration perspective or an update perspective, you'll have to update your core Kubernetes installation, and then the add-ons are going to come with their own, the add-ons are going to come with their own update setup. Right, and that's why we are actually going to, or we are planning to use Salt to deploy the micro OS and deploy Kubernetes on top of micro OS. So that's our plan as well. But then the problem is, how do you manage everything that is going on top, like containers? Your application is going to now be available as different set of containers, right? So you might have this in like 10, 15 containers, and then you need to manage everything. And this is the part where Kubernetes comes into place. Question? Right. That's the plan. Thank you. Yeah. Good. And yeah.
What's the main motivation for this transaction update feature? And it's still RPM server.
So what's the main thinking of having transactional updates, or still keeping zipper in? Or
Well, is it still RPM?
So I can answer what it solves. So the problem that we are trying to solve is to make sure that we can do the auto update on the system and roll back in case of a failure. So we need to make sure that we don't update the system multiple times per day, and we always can run into an unfortunate situation of something is not working or a dependency is not there and so on. But we make sure that we build everything together. We test this as a transactional update. If this works, then you actually go apply this to the system, and only in the unlikely when something is wrong, then the system is able to roll back to a stable version. The RPM, Thorsten, you want to jump in?
Yes, so the main thing like production updates is if you have only a new update like before, you can design the system. If you want to make a bigger changes, you can open the handle, for example, updating the laserability version, where you can add whatever. With the running system, your running applications are specified. And this is something you want to avoid. So you can do the update, and it does not impact the running services. And if something goes wrong during this update, you can delete it, and the system is still in the clear state, and there's no leftover from the failed update. And when you put clean, if you see all it's less, it's with 11, it's with the updates, you can bring the running system to a smooth level without problems, And what do you do to activate it? Because fixing updates doesn't make sense to only update the API. So we should be correcting the big updates that make sense because the running system is not affected, but we need to reboot and activate the system. And there is always a question of more important. Running services, so that my website or whatever is not going down most of the time because the update gets Apache and Apache breaks and it needs to be started. Was more important to not reboot because my database needs to know what to come up again after the boot. And so this two things, and unless we try to avoid the reboot, right for us, the goal is don't protect our services. And we support that again because they fulfill everything we need to explore, need to complete. Just between the server, the snapshot, and holiday, it doesn't matter if you install a tool in your subdomain or if you update your RPMs or however you want it, it doesn't matter. And it's always decided for the system. And RPMs, we have the full strength for it to deliver it, or build it to deliver it. And the customers have to full time on getting the updates to verify that they are okay. Put your own policies complete, for example, some customers have a policy every update needs to be tested several days in the system, digitally signed with some keys, and then they are only allowed to deploy it on your system in the DMZ or whatever, in the data center. And these values at the end and don't take this
Good. Any other question or comment? Not? Then thank you very much for joining and hope you want to hear more about this.